Hello everyone and welcome to this podcast in which I'll be showing you how to visualize the data stored in your database, not in a textual but in a visual manner to make it more accessible to your users in your very own custom web application. For this I'm going to use yFiles for HTML, a JavaScript HTML5 diagramming library for the web, which you should evaluate and try. And if you want to follow along this tutorial, make sure that you've downloaded yFiles for HTML and already played a bit with the package. There's a separate video in which I introduce the package contents. Make sure that you've seen it before you dive into this short little tutorial. Specifically in this tutorial, I'll be using Neo4j, the popular graph database, as the source of my data that I'm going to visualize. So let's get started. I'll be starting and scaffolding my application, which I'll be putting into this directory using Yeoman. Yeoman is a scaffolding tool which allows us to quickly scaffold any type of application. There's a public generator available for yFiles, and let's just find it. There it is, install it, and the generator will allow us to scaffold all the files and tool chains to conveniently edit and run the application. In this case, we're going to build the yFiles app in the application in the directory Neo4j. Neo, and for this we need to tell it where to find the yFiles package that we've just downloaded. So let's look at let's just get the directory, copy it over there. It wants to know where we've put the license. We can just accept the default, and we're going to use ES6 modules. And I'm going to add some modules by default. We are interested in the algorithms. We would like to use the at least one layout. Let's start with the hierarchical layout and maybe the radial layout. And we're going to use, of course, the view component, and we would like to have some editing later on. So let's start with that. We can always change it later on. We're going to use ES6 for this demo, and I would like to use Webpack. We're going to use Webpack 4 to actually build the JavaScript file so that it will run in browsers not supporting ES6 later on. We would like, in this case, I'd like to use WebStorm for editing the demo, so I'll scaffold some project information files to make WebStorm happy and productive. I'm going to use Yarn in my demo. Feel free to use npm in your case. So here we go. While Yarn goes and downloads necessary files, that's mostly Webpack related stuff, we can wait for it, and I'm going to go to WebStorm and open that file, which should be available in any moment. So let's go to Documents, to the Neo4j. As you can see, there's already the Neo4j file. Let's wait for it to fetch all the Webpack libraries. After that, we get a simple application that we can already run and test. So here we go. So here's the project that we've built. It's a Webpack-based project. It contains a simple script which basically consists of the imports which I specified previously, the initialization of the license, and a very simple basic file. Let's see how we can run that file, show the scripts that we have, and start the application and see whether it works. So there it is. Very simple application, nothing to see here. Let's try to actually visualize our database. For this, we're going to need the Bolt cipher adapter, which is the driver of Neo4j that will help us to access the database, which is available via the web interface, but also via the Bolt protocol. So luckily there's a package available that I can just install and add to my application. It's called Neo4j driver. Let's fetch that driver. And once it's there, I can do this. Import Neo4j from Neo4j driver lib browser Neo4j web, because we're actually scaffolding a web application. And the next thing to do is that we are actually going to instantiate the driver. So we're going to say Neo4j driver equals Neo4j.driver, and we need to specify the location and the protocol, which is the Bolt protocol. And in my case, the application runs on this IP, the Neo4j server. So let's just fetch this IP. And I need to authenticate against the database. Let's use the basic authentication, and in my case I have a very simple username and password. Don't tell anyone. And that should be it already. We should now be able to actually connect to our database. Let's see whether that worked. Let's start the development server, which will continuously reload and run our application in the background. Of course, start. So, and now let's go to the console. Still the same graph, of course. And of course, I made a mistake. Let's see what happened. I forgot to include a specific module. So let's do import yFiles. So like this. Save it. Webpack will reload, and this time we get the automatic layout and no more errors on the console. Let's see, here's my app, there's my script. As you can see, when reloading the page, we are actually stepping over the Neo4j driver, and we can see that the driver successfully initialized. So let's start with our first query. There's a lot of functionality already in that file over here, and we're going to strip most of it because it's not important for us in this demo. Let's just keep the Neo4j driver, keep the graph component, and get rid of all of the rest over here, which is unnecessary for this one. So what we're doing is instantiate the Neo4j driver. We're instantiating the graph component in the UI, and then we're going to actually load the graph, which is going to be an asynchronous function, which I'm going to define now. And in that function, we're going to actually query the database. So let's define a results. So we're going to await a Cypher query. Let's call it run Cypher query. And the query should be match all the nodes that you can find and just return 25 instances. So how is run Cypher query going to look like? Let's put it over there. Query. So it's going to be a helper function, so I'm going to improve that a bit for later on. First, we need to instantiate, open up a session. For this, we're going to need the Neo4j driver and call session, tell it that it's going to be read access to the session only. Then we're going to do the query. We're going to run the query with some optional parameters. This is going to be an asynchronous call, so that's why I'm awaiting the session run call. But after the session, after the run call returns, or when it froze, we should always be closing the session. So that looks almost fine now. Let's see whether this works. Let's just output the result over here. Oh, it tells me I've got to add the await, the async function over here. It's an async function. So here we go again. Compiling work this time, and we can see that it included the Neo4j driver. So what happens once we reload the file? We run the query and we actually receive a record of 25 elements. And as you can see, let's take a look at those elements. In this example, I'm actually looking at the movie sample database, and as you can see, I got some elements returned. This is the matrix with the tagline and some additional data on it. So I actually got the data to JavaScript, and that's the most important thing in order to actually display data with yFiles for HTML. All I need to be able to is to get a grip to that data in JavaScript, and then I can pass it to yFiles for HTML. So there's no specific connector available for Neo4j in yFiles for HTML, but I can use any kind of data that I have access to in JavaScript in order to bring that data onto the screen. So for this, we're going to actually now build a helper data structure that we can pass on to a utility class in yFiles for HTML in order to specify the nodes that we want to see on the screen. So what we're going to do is we are going to check the node result, which has a set of records, and we're going to map those records, and for each record we're going to use the Bolt API to actually get the field that we called node. So we called it node over here, and that means we need to pass in node. So the nodes that we have is this, and let's see whether that worked. So now we have an array of nodes, and the next thing we are going to do is to pass those nodes into a graph builder, a so-called graph builder. So we're going to remember a builder over here, and we're going to tell the builder where to get the nodes from. So this is where we're going to pass in the nodes array, and we would like it to directly populate the graph that we're displaying on the screen. So once we've told it where to fetch the nodes, let's just call build graph and see what happens. Whoa, yeah. There it is. That's actually 25 different nodes. They all look the same and very boring. And they are located at the same location, so there's nothing to see here. So there's still a lot of things that we can improve, so let's just do that. So first of all, we're going to change the default size of the nodes. So we're going to take the graph, and there's a property called node defaults, and where we can, for example, set a new style and size. So we're going to use a shape node style in this case, and where we can specify the shape to be an elliptical form, and we can set the fill to some color light blue, and we also like to change the size to a value like 240 pixels. And note that WebStorm automatically has imported the corresponding types, except for the last one, which I didn't type properly. So let's see, we have 25 nodes in elliptical form, and now let's add some labels to them. For this, there's actually a property on the builder where we can specify for each node a simple binding. So if the node has properties, which is the case for the Neo4j API, and it has a property named title, then we're going to choose that. Or else, if there's a property named name, we can use that one. Let's see if that works. Yeah, looks better. And now, most important thing, obviously, is to actually move the nodes apart so that we start seeing something. So we're going to apply a layout. In this case, I'm going to use a simple radial layout. Let's see whether that works. Yeah, here it is. So we have a couple of nodes, but still there's no relationships in this graph. So let's change that. So we're going to use another query to the database. For this, we need to first tell Cypher which nodes we're interested in to get the relationships in between. So we're going to use the nodes that we have, and going to use their IDs. So for each node, we would like to have the so-called identity property, and let's put this into node IDs. So that's just a collection of all the nodes that we queried in the first run. And now we're going to fetch the edges, the relationships. So we're going to await another Cypher query, and this time the query goes like this. We're going to match a node n, which is connected via a relationship to a node m, where the ID of n is in the set of IDs that I'm going to pass in, and the ID of m is also in that set. And I would like it to return all distinct edges, but only the first 100, just to be safe in this case. In case you have a large graph, this could be too much otherwise. So I'm going to pass in the node IDs, and let's just log the edge result and see if that works. So we don't need to have the second log anymore. So we're going to fetch relationships named edge, where the node between all the nodes that we already have queried in the first run. Let's see what happens. I get an array of 35 records, and let's inspect those records. This is what they look like. So it's a key inside that, and let's see how they look like. We see that there's a type of the relationship, it's acted in, and there's also a start and an end property, which tell us where the nodes, which IDs of the nodes the relationship connects to. So let's tell that tell this yFiles for HTML so that it knows how to connect the edges in memory. So we start by mapping the result records to a simple simpler structure. So for each record, again, we're going to fetch the edge element, and let's put that into an edges array, and we can tell the builder where to fetch the edges from. But in order to actually establish the mapping from the source to the target node, we also need to tell it how to identify the nodes. So there is a node ID binding. So for each node, we can use the node identity property, or rather its string form, as a key to the node. So this tells yFiles how to identify a node based on the data that we got from Bolt, from the Cypher query. So the next thing is to tell it how to where to find the information, how a relationship maps to its source node. That's the source node binding. And for each edge, we can use as we've seen, the start property. It's to string form. And likewise for the target node binding, we can use the end property, and it's to string form. So that should be it already. Let's just add a label binding for each edge. We want to use the edge just like for node label binding. We're going to use the, now it's gone, we're going to use the edges type. Let's see if that works. Reload it. I declared the binding too early, so let's move that further up. And remove the log over here. Let's see if that works. Now, nice. We get the graph with the nodes, the relationships, and the types of the relationships. So let's improve the visualization a bit more. We're going to first make it easier for the user to actually interact with the graph. That's actually very, very easy. In the case of yFiles, we're going to use a so-called input mode, which is responsible for recognizing and identifying the user gestures. So we're going to use a graph component and tell it to use the viewer input mode. This lets us not edit the graph, but lets us select elements and use the keyboard to interact with elements. And we can also use it for specifying tooltips and context menus and so on. So let's start by adding a tooltip. Let's put this into a variable over here. So the graph view input mode, and there's an event for tooltips. So whenever the input mode wants to query the tooltip for a certain location the mouse hovers over, it will fire this event, and we check whether the item is provided and the item has a tag, which will be the business object associated with the element, which in this case would be the Neo4j object. So let's see if it has a tag and the item has actually properties, which is the Neo4j properties bag. Then we can set the tooltip to a value like this. Let's do a simple HTML return value. So we're going to return a list, and the list will contain all the entries in the tags properties. We're going to map these for each element in the properties. We're going to map this to a list item like this. So closing tag, and so that's and inside of this we're going to show the key and the value like so. Let's add one more colon, and so the array, that's the key and that's the value. It's going to be put into a list item for each object, and each of them going to be placed into so actually that's just an array. Let's join these arrays and put them into a list. I think that should do it. Let's see if that works. So let's hover over one of them. No, it didn't work. So what's the problem? There's an item and there's a tag, and the tag has properties. Combine of all of them to a list item. Let's just debug this quickly. So whenever I hover over a node, let's see if there's an item. It has a tag. That was just a label. So let's hover over a node and see. So in this time we have the movie. The movie has properties. So we should actually get into this branch. Let's see what's this one. It's this expression. So it looks like HTML to me actually. So what's the problem? Step over it. tooltip is actually a list. Looks good. Oh, okay. So there wasn't actually a problem. I just hovered over the wrong item. So here it is. So there's details about Emil Efren, and there's details about Joe Silver. Okay, cool. So next thing is to actually add some interactivity and some automatic layouts. So in this case, we're going to intercept the case when the user actually double clicks on an item. So there's a specific listener for this case. It's going to be an asynchronous method. So asynchronous, and that's how it looks like. That's what it looks like. So if it's actually an inode that we're hovering over, let's check that, because we only want to register for double clicks on a node. We're going to tell it to actually not do the default action, so we're going to handle the action ourselves, and we're going to calculate a new layout centering around the item that has been clicked. So we're going to use a radial layout. Let's call that layout, and the layout will use a custom policy for the nodes that we're going to put into the center. So there's a special key for it. It's called custom, and we need to specify which are the custom nodes. So we're going to use the radial layout data class for this, which allows us to add more information like this. And for this, we can use the center nodes and specify the items. In this case, let's just add the item that the user clicked on. So we are now telling the layout to use a custom strategy for determining which nodes to put at the center of the graph, and the custom elements will be exactly the elements that the user clicked on. So now let's run the layout. Because there's a morphing involved, we need to await we can await that. So let's call morph layout. We're going to pass the layout data, and let's do a quicker morph duration so that it doesn't take so long. Let's do just half a second. That should be it. Let's see whether that works. So double clicking on an item now moves the item into the center of into the focus of the visualization. Cool. We still have the tooltip in place. So now, as you can see, there's actually movie nodes and there's actor nodes over here. So let's change the appearance of the movie nodes so that it's easier to see which ones are movies and which ones are regular actors. So how will that work? The graph builder is the builder class is responsible for actually creating the nodes, and it actually offers events that we can listen to. So let's just listen to the event whenever the graph builder creates a new node, and in this case we're just going to check if the source object, the business object returned by Neo4j, whether it contained the labels properties, which is the case for nodes, and whether that labels includes name the string movie, and if so, we have identified a new movie node. Now let's simply set another style to the item, and that style, let's make another shape node style, call that movie style. We can put that outside of the event because we want to share the same style among the elements. And let's make the shape, for example, round rectangle, and the fill yellow. And we also change the size of that specific node, so we're going to change the node layout. So let's just say it's a bit more narrow but higher, and see what that makes a difference, whether that makes a difference. Looks like an exception. There's a problem in my code. Rect is not defined. Oh, okay. Got the import again. Whoops. There's still a breakpoint in here. And now we have yellow round rectangle nodes for the movies, and the blue ones for the actors. One more thing, the labels look pretty hardly readable at the moment. Let's change the style of the edges and the labels too. So similar to the way we defined the defaults for the nodes, let's just change the defaults for the edges. And so let's use another style, or simply change the placement of the labels first. So we're going to change the labels and specify the layout parameter. We're going to use the so-called edge path label model, where we can specify the distance of the label to the edge, whether it should auto rotate, and on which side of the edge we would like to have the label displayed, in this case above the edge. So the edge path label model, and from this we would like to see the default parameter. Now there's still warns me, distance, auto rotation, side of edge, should be fine. Let's see. Yeah, and now we have nicely rotated labels along the edge, and let's use a nicer style for the edges. So we're going to use a polyline, new polyline edge style, and we're going to use a medium thick blue stroke. We want it to look smooth rounded corners, and the target arrow should be a default arrow also in blue. See whether that works. And now we have nice blue arrows with blue arrowheads. So this actually concludes this little screencast. We with only about 60 lines of code, we created a custom visualization from our Neo4j database using custom UI, custom layout, and interactivity, as well as tooltips. And of course, that's not all. There's a lot more that you can do with yFiles for HTML. Be sure to check out all the demos that we have on our website with the hundreds of different styles. And I'm perfectly aware of that this isn't really a great looking visualization, but this is just for the proof of concept that I wanted to do for this application. So you can see that there's a lot more options that you can have for the visualization. You can embed the component into your own application, be it based on AngularJS or React or Vue.js, and you can use more complex data binding and more complex visualizations to actually visualize your database and the contents of your database. You can apply different layouts and so on, but this is the story. This is a story for another screencast. And you will find the source code for this demo in the link below the video over here. Be sure to check back and give a comment. That's it for it today. Bye bye. Thank you.